Hi, I'm Merritt, and I'm from Nathan Bishop Middle School, and I'm in 6th grade. Today we're going to be talking about water chemicals in Providence. I'm going to start off with my research question is, what kind of chemicals are found in Providence water sources? That was a question I had, and a few people asked me, so I decided why not do it. Before we do that, people kept asking me the question, what is so interesting about water? Well, we all drink it, that's for sure. But what could be in it? That is a great question with a great answer. Inside of water, we can find pH, nitrates, oxygen. You've probably heard of one of these. If you've ever been to a pool and have seen people testing, that usually means they are testing for pH, nitrates, and oxygen. Just like they are important to test for a pool, they are also important to test for our bodies. I was inspired by water at a young age, always jumping in puddles, always swimming at our local pool. Water is everywhere, in our air, in our food, and of course we drink it. So why wouldn't it be important to know what's in it? That's what questioned me one day as I was sitting next to the pool breathing in the chemical smell. It might not seem like a big idea, but it is. As I said before, water is everywhere. My question started out simple. What is in water? Then I moved to the question about chemicals. I wanted to learn more, so I decided to find out how water worked. To get water samples, I used water bottles. In the end, I found out what was in water and how it can affect things. I used the globe, pH, nitrates, and dissolved oxygen protocols. I came to the conclusion that pH, nitrates, and oxygen can vary based on where they are located and what their surroundings are. My hypothesis is I think that surrounding land could have an impact on what chemicals are found in water. This is a pH chart. pH is a way to measure the amount of hydrogen ion concentration, H plus or H3O, in water. The higher the concentration, the lower the pH. Let's go back on how water actually works. A molecule is based up of one oxygen atom with two hydrogen atoms. When two water molecules come together, they can ionize. In this case, that means that one hydrogen molecule switches for two electrons. That causes one molecule to be positively charged and the other to be negatively charged. One becomes H3O plus and the other becomes OH minus. As we can see here, it's talking about the hydrogen ion concentration. The pH chart is one of the steps to actually measuring pH. pH equals negative log or H times H plus. Nitrates. To the top right is a nitrate molecule. The center contains a nitrogen atom with 3 oxygen atoms. In the bottom right corner, there is a nitrogen atom. A nitrogen atom has 7 electrons circling around its proton. In these slides, we're going to talk about locations and water sources. But first, we're going to talk about my method. I used the globe bottling a water sample protocol to collect my water samples. I had to first find bottles that I could use to store water in. Then I had to go to my location and collect each sample carefully by putting the bottle under the water until all the air bubbles were out of the bottle. I had to repeat this 3 more times to collect each sample. Then I tested each sample at the school the next day. The next 2 slides will tell a little bit about each location. At the top is Massachusetts River. And then we have Seekonk River, which is actually running into the Narragansett Bay, so we might see some similarities there. And then we have, of course, the Narragansett Bay. This is the Seekonk River. It's icy, cold, dark. The water is murky with seashells. The shore is rocky. Branches are scattered around with tons of decaying other plants. Narragansett Bay, it's icy, cold. There's rocky shores. It's mossy. There's plant life and fish. Massachusetts River, there's fresh water. It's cold, icy, full of bark and leaves. And then tap water is just cold, filtered, and clear. These next few slides are going to talk about my results. So on the left is going to be the date and times. I got them for each day, and then on the right is going to be my graph. This is going to be the Seekonk River. pH stayed the same pretty much throughout the entire time. Oxygen stayed pretty medium, then went down a little bit, and then went up a little bit. Not too much of a difference. Nitrates started pretty low, spiked up just a little bit, and then went down just a bit. This is the Massachusetts River. This actually surprised me a lot. It started off really high and then it went down really low, then went back up. That is for nitrates. pH stayed the same throughout the entire thing mostly. The oxygen stayed the same. First two went down a little bit, and yeah. Next, Narragansett Bay. Again, pH stayed the same. Nitrates, this surprised me too. There's no nitrates on the second day. Otherwise, first and third day are the same. Oxygen was pretty medium place, went up a bit, and then went down a bit. Tap water, this surprised me so much. Only had the pH was the same entire time, no nitrates whatsoever. The oxygen was only on the second day, except it was a little amount for some reason. I don't know why. Okay, here's all of them together. Of course, you can see the pH pretty much the same. Nitrates, the Narragansett Bay and tap water, there aren't as many nitrates. Definitely spiked up in the Massachusetts River. Seekonk River, it's up and down, up and down. Narragansett Bay, of course, it stayed the same, but again, not as much. Oxygen, barely any in the tap water. Some in the Narragansett Bay. I mean, it spiked up on day 2. A little in the Seekonk River. It didn't go too high. Again, it didn't go too high in the Seekonk River either. And yeah, pH pretty much stayed the same. Now this is a question someone asked me. Can different chemicals in water affect plants? That was a question I had too, actually. It actually can affect plants. For example, apple trees can only take in from 5 to 6.5 pH or else they will die. pH can be found in soil, water, that includes rain. This is my conclusion, the future of water. In conclusion, I feel that these findings can inform people about what they are drinking. The land actually did have an impact. For example, I found out that there is less oxygen in areas with more fish living in that underwater land. I plan to continue my research across the world to inform people about what is in their water and how it can affect them. Another question I might visit in the future is, how is water in plastic bottles compared to other water sources different, and why? Is there a way to preserve our water? And questions people might have about water. Not to mention, more than 35% of our world population doesn't have clean water sources, so we might be able to fix that. Definitely not soon, but hopefully we can try to find a way. Then credits and bibliography. You can read this yourself. This is mostly just pictures and how I learned about lots of this stuff. I also I thank you for watching, and then I also thank George Groves and Rory Merritt for helping me with plants and how they work. I also thank Eli Yee for helping me with researching about water.